Okay, question 2. Figure 3 shows a ray of light striking a mirror. So we can see that we've got specular reflection going on here, and that's the angle of incidence equals the angle of reflection. And it's going to ask us, how do we measure the angle of reflection? So the crucial part is we always measure it from the normal. We never take that angle there. So it is the reflected ray and the normal. So the angle of reflection. So what it's asking us is, if this is the angle of incidence, that there would be the angle of reflection from the normal and the reflected ray. And we can see that's D. Figure 4 shows 2 types of lenses. So I've got a convex lens there and then another convex lens here. And it says state one used for a telescope. Everyone knows it's for, say, magnifying far away things, making them bigger. So to magnify distant objects, for example, I want to see a star, a planet, a moon. So that's that. Which of these describes the lenses? So we've got 2 types of lenses. We've got a concave lens. So a ray 90 degrees or normal to the surface goes straight through. And on a convex lens, it is diverging. On a concave lens, it is diverging. And on a convex lens, it is converging. Again, that hit 90 to the surface, bend, put arrows on our rays, and there we go. So it says, which of these describes the lenses? Well, we'll go back. I think we're going to see that they were this, and we know that these are converging. So we can see, yep, brings it to a point, and this one is doing the same in effect. So both are converging. Next one. The focal length of lens Q is 0.14 meters. Perfect. It's as I want it, so there's no centimeter change. Calculate the power. So this is pick one flower over the focal length, and we can see we just got to put the numbers in. So there we go. 1 over 0.14 equals 7.1 diopters. D. A student is in a laboratory that has windows. They're given a converging lens and a piece of paper. Describe how they could produce an image. This wasn't done particularly well nationally, but just think about, if I gave you a lens, how could you make a picture on the wall? There's the wall. There's the student. Give them a giant, that's meant to look like a lens, not someone's ripped out heart. Let's go there. They've got a lens. And here's the window. Well, what they're going to do is they're going to move this forwards and backwards until they've reached the focal length there, and then we'll have an upside down image. So let's put a tree there. We will have the window and the tree upside down there. So the crucial part is, well, with that lens, I'm going to move forwards and backwards to get the right focal length, and then I'll see an upside down image. And they want to do it on a sheet of paper. So let's get rid of my wall. Let's change that to a sheet of paper. That's ultimately what they're going to do. So delete all my doodles. Set up the lens, and you've got a mark for just saying the lens needs to be between the window and the piece of paper. Okay, so we just know it's window, lens, piece of paper. And then the next part is a mark for saying, and we're just going to adjust this length until we get an image on the paper. And there we go, question 2.